All right, we're live. Okay, so I'm going to get rid of the pictures on the bottom so we have a little more space. So what we're going to be doing here is we're going to go through lesson 1.1, which in the book is called graph, and this first chapter, chapter 1, is pre-calc review. I'm probably going to go just a little bit quicker on this review than I will on the calculus material, but I'm not going to rush through it either. So we're going to take the first lesson today. Let me show you. Yeah, it's called an introduction to functions. Oh, I wanted to show you this. If you go on the website, which is right here. So when you're on the our course website, you come down a little bit ways from the book, just past my info. Right under course resources, you'll see this link for calculus website. I don't think I showed that to you yet, but when you click on that, I have a whole independent site here. Maybe I did show it to you. Anyway, and then when you click, especially you want to go to course notes. And when you go to course notes, these numbers don't match up with our book. But when you're on our website, let me get back here. When you're on our website, and for example, let's say you're on chapter 2, and we're going to be talking in lesson 2.2 about limits. And when you click on limits, it'll take you to the appropriate lesson. Now, this one happens to be 2.2, which matches perfectly, but it's from a different book, and it won't perfectly match up. But anyway, when we get there, and then when you click on the little Rubik's Cube icon, it'll have sample problems for you. Okay. So I don't know if I showed that to you or not, but there we go. All right. So when you talk about a function, there are two. Let's see. Let me make this a little bit bigger here. I'm going to get rid of that. And so there are two big names that come up. Leibniz, who is one of the co-discoverers. Notice I said discoverers of calculus. The other one is Isaac Newton. Leibniz is huge, and on the right, another huge name, Leonard Euler. We'll be hearing more about Euler. In fact, the fact that his last name begins with E, you probably know this by now, but that famous number, it's on your calculator, and it will have a lot to do with our course, the number E. Okay. So let's here you have a picture of Euler is the guy that came up with function notation, this f of x. And okay, so he's going to be huge. I don't normally show you slides that are from the book, but here we have it's a pretty good demonstration of this first lesson. So, an introduction to functions. So, you should know that a relation is what? It's not anything special. A relation is two different sets related, and it doesn't matter. There are no rules, no holds barred. You can have points anywhere. So anything, basically. I mean, it's like you know, when you hear the saying, "Well, who did they hire?" or "Who's eligible for that job?" and somebody will say, "Well, all I need is a pulse." Like very little requirements. That's relation, nothing special needed. Just any relationship at all. On the other hand, a function, as you know, is restrictive. And you can't have two values of y for the same value of x. So the x's are the domain, the y's are the range, and we're going to take a look at. So here's an example of set A is that's your x values, your domain. The set B, that's your y values. And the important thing here is that each x must go to only one y, like you see here. This is okay. This is legal. When you look at a set of pairs, you can see this by looking at ordered pairs too. And when you look at the top set of ordered pairs, -2 only goes to one place, 3. Likewise, 0 only goes to 0, 2 goes to 3. No value of x goes to more than one location, so that's a function. But in the second set, set B, -1 goes to 2 different locations. It goes to a 1 and to a -1, and that's not a function. I mean, I always think of this as an example of what's a function and what's not. If I went to the store and bought a gallon of milk, and the same day, in fact, an hour later, one of you goes to the store, gets the same gallon of milk, and gets charged a different amount than I got charged. Of course, we would never stand for that in America. Unfairness, all that type of thing. I mean, that is not a function. When we both buy a gallon of milk, we have to be charged the one same amount. Yeah, and then here we just talk about function notation. We usually use f of x. How do you evaluate? Function notation has a wonderful principle to it. You can show what's being substituted, like you see in this second line here. In the second line, you see how there's a -2, f of -2. So when you plug in a -2, out comes a 9. After you calculate the whole thing, you get a 9. So f of -2 is 9, and that is basically, I love that because that's an ordered pair. It's -2, 9. -2, 9. So function notation has a lot of advantages. And you can also substitute in not just numbers. If f of x equals 4x minus x squared, how does one find f of x plus 2? By substituting x plus 2 in every place there was an x. Hammering it out, the x plus 2 squared has to be figured out, bring it all together. Finally, we get our result. I'm going to go out of this presentation mode because I want to show you something. Let's see, how do I do that? Can't remember. So anyway, you've got ordered pairs. Oh, I know, we got to unclick that. So really, we got an ordered pair here too. The ordered pair is x plus 2. And then the result is the y coordinate. So here too, even though it's algebraic, we end up with an ordered pair. Okay, I know this is probably all review for you guys, but all right, where are we now? Function 8. So, domain is a very important term, and it's what? All the values that x can be. Is there, so what you almost have to ask yourself is there anything x can't be? And in this case, is there anything you can't multiply by 3 and add 5? No. So the domain is every real number. And real numbers is what? The default. We're gonna yeah, we might talk about some other domains, but that's basically where we're headed. All right, now this function has an interesting, it's a square root of x minus 3. the principal square root of x minus 3. Is there anything x can't be here? And because of the real numbers, we would have a problem if we picked an x that was less than 3. It's okay to have x be 3 because you can take the square root of 0, but it sure can't be less. So the domain here is 3 and above. Yeah, this is just more demonstrating the concept again that if we have a function like 3x minus 3, we can find f of negative 3. And we can find f of x plus 1. And we can even find f of triangle, any symbol. If you want to find f of triangle, again, substitute in triangle where there was an x, and again, you get an ordered pair. Triangle, comma, 3 triangle minus 3. So we had a little problem with the domain on our square root problem, and we would have a little problem with the domain here too. We know that a no-no in algebra is we can never have 0 in the denominator. And here we have the possibility for that happening. If x was a 1 or if x was a negative 1, that denominator would wind up being 0, and we can't have that. That's just garbage. You cannot divide by 0. And so for the domain here, we have to exclude x being 1 and x being negative 1. Anything else will work. It's okay if the denominator is negative. So the only thing you can't have is when x is exactly 1 and when x is exactly negative 2. So here we just write for the domain the two things that x cannot be. Okay, so now this is extremely important. We're gonna talk about a difference quotient, and we pick two points. Here they're in the first quadrant, and this point here we could just call x comma f of x, and this thing here, this line we're going to call f of x. Okay, so this point is just anything unspecial x plus, and then if we move over, we call this distance from here to here, that distance is h, then this point is x plus h. And when you plug in x plus h, you get f of x plus h. Okay, so now I've got 2 points. What's the slope of that f of x line? Well, it's the y-coordinate from this point minus the y-coordinate from this point divided by, rise over run, and the run is h. So this right here, that thing in the box down there is a difference quotient, f of x plus h minus f of x all over h. Now, sometimes our book uses delta x. They'll use delta x in place of h, and that's fine. I'm not trying to confuse you. I only delta x is a little bit thicker and gets a little bit harder when you want to square delta x. You really have to put it in parentheses. Anyway, sometimes I'll usually just use an h like this. All right, so finding a difference quotient is going to be the first really important thing that we all have to nail down. So here, let's just do this one together. I'll start over. We'll come to the right here. So if we take the function 2x plus 1, and I'm going to just change the color so I get a black here. So let's say that's our function. And that, let's say the directions say find the difference quotient. Extra I there. So that means we need to find this. That quantity we were just talking, that's the difference quotient. It's that slope formula for those two generic points. So what is f of x plus h? Well, that's the first thing we got to figure out. F of x plus h is when you come up here and in place of x, you plug in a x plus h. So that would look like this, which is, of course, 2x plus 2h plus 1. All right, so now we take this f of x plus h, 2x plus 2h plus 1. We subtract the original function. Make sure you do that in parentheses. And we divide by h. So on the top, the 2x's go away, right? You got 2x and you got a minus 2x. The 1's go away because you have a 1 minus a 1. And that means on top, you just have 2h over h, which is, of course, 2. The difference quotient for this particular function is 2. All right. Let's do this one, or something, yeah, x squared minus 7. We'll do this one live here. So f of x what was that, x squared minus 7? All right, so we want to find the difference quotient. By now, I'm going to just write it one more time. We all know that this is a difference quotient. You need to have that memorized. All right, so to find the difference quotient for this thing, I first have to find f of x plus h. And that would be x plus h squared minus 7. Get rid of that mark down here. All right. So that's what? X squared plus 2xh plus h squared minus 7. So there's, by now I'm assuming you guys can all square x plus h, and you know that middle term gets doubled. But you can hammer it out using, the handshaking, or the, what do you guys often call it, FOIL. All right. So there's f of x plus h. Now from that, I'm going to subtract the original function f of x. And this time I'm going to use a vertical format here. So we're going to subtract x squared minus 7. And I can line up the terms that I wish to subtract. That'll give you. Okay, so we've got the subtraction. That's all over h. And of course, we can factor in h out of the top. And 2x plus h all over h. H's cancel. And there's our difference quotient. 2x plus h. I'm going kind of quickly here, but I'm assuming you guys are all on board with this. Let me know if you want more detail or you want me to slow down. And if I mess something up, let me know. All right. So we've done those. Yeah, let's do another challenge. 2x squared minus 3x plus 2. Well, let's do that one. I don't know if that was a +2 or a -2, but it doesn't matter. Here's our example. The goal, find the difference quotient. Okay, so we know by now we need to start by finding f of x plus h. So that's 2 times x plus h squared minus 3 times x plus h minus 2. So that's 2 times x squared plus 2xh plus h squared minus 3x minus 3h minus 2. Finally, that's 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2. Okay, from that, we can now subtract the original function, which up there on the top, and I'm going to line up the terms so they match. So that leaves you with 4xh plus 2h squared minus 3h, and then in the difference quotient, we know we have to divide by h. So we can, again, factor an h out of the top. 4x plus 2h minus 3 all over h. And there's our difference quotient, 4x plus 2h minus 3. All right. Yeah, it's time. So this one we can do right here on the page. We're going to do one where we have a denominator. All right. So the first thing you're going to want to do when you want to find you're going to have to find g of x plus h. So I already substituted in the x plus h for the x. That would be 1 over x squared plus 2xh plus h squared. All right. So there's the original. Now from that, I have to subtract the original. So I can't line up vertically like I did before. I have no choice but to write it like that. How in the world am I going to subtract that thing? Answer by, the only hope we have is to get common denominators. All right? So let me grab my red pen. So this one I need to multiply by what? X squared over x squared. This one I need to multiply by x squared plus 2xh plus h squared, top and bottom. Okay. That will then give us a common denominator. Well, let me rearrange this a little bit. Let's get rid of these stray marks. Okay, so now my common denominator is going to be this x squared times x squared plus 2xh plus h squared that we have in both cases here. So we have a common denominator, so we can bring it together. And on the top, we have x squared minus, and then this whole thing. Okay, we still haven't divided by h, by the way. Remember, we got f of x plus h minus f of x all over h. All we've done so far is done f of x plus h minus f of x. It's just, we'll get to that. So can we simplify this? Yeah, we can at least get rid of what? The x squared minus x squared is gone, and everything else is subtracted. All right, so now we're down to that point. And we still haven't divided by h. So I'm going to divide by h now. And all I have to do to divide by h is to put an h in the denominator. And we can simplify the numerator just a little bit, right? We can take an h out of that. Now we've got this h here, and that cancels. And there is our difference quotient. Okay, so we've got, so that gets a little bit messier when you have to subtract fractions. You got to deal with common denominators. Hopefully that, I mean, it's maybe not fun, but I'm sure you recognize how to do that. Okay, here's another one with denominators. Maybe that's too similar. Likewise here. Let's do this one together, okay, as our last example, or an example. This time we have a square root problem, the square root of x minus 3. And again, I list the domain here that x has to be greater than or equal to 3, because if x was anything less than 3, you're going to get a square root of a negative, and we're outside of the realm of real numbers. We're into imaginaries, and we don't want to do that at the moment. So the very first thing we're going to have to do is figure out f of x plus h. Well, there it is. Okay, so now when you put together the difference quotient, we are going to have to do f of x plus h minus f of x all over h. So there's the difference quotient. Now, how can we possibly, usually you want to get rid of that h on the bottom. And how in the world are you going to cancel it? And the answer is conjugates. The only way to get rid of that, get that h out from under the square root sign on the top, is to multiply top and bottom by the conjugate of the top. What do I mean by a conjugate? This is kind of an important. A conjugate, the conjugate of a plus b is a minus b. The conjugate of x minus 2 is x plus 2. So it's just what? It's the thing that when you multiply by it, when you multiply conjugates, what do you get? You get the difference of two squares. So x plus a times x minus a is x squared minus a squared. So what we're going to do down here is take top and bottom by the conjugate of that top. And of course, if we do it on the top, we have no choice but to do it on the bottom. Okay, so what happens? When you multiply conjugates, you get the difference of two squares. Well, it's that square root of x minus 3 squared. Goodbye, square root sign. It's that minus the other part squared. X, the square root of x minus 3 squared is x minus 3. And you notice we have h out from under the square root sign. When you simplify the top, what do we get? Well, x minus x, that's gone. Negative 3 minus a negative 3, that's gone. So what's left on top? Okay. Squared. So what happens when you do that? X minus x is gone. Negative 3 minus, so we get, so what am I missing here? We get h over h. I'm feeling I missed something there. Anybody see what happened? And so if I take this and square it, I get x, that thing without the square root sign. And if, oh, and I'm sorry, I forgot the bottom. Okay, that's what happened. Let me just fix this up. All right, so on the bottom, we get h times square root x plus h minus 3 plus square root x minus 3. Okay, on the top, like I said, you just get an h. On the bottom, you get an h, and you get all this other wonderful stuff. And now the h's really do cancel, and there is your difference quotient. Okay, so conjugates become a very important part of solving. Let's see, did I get a text message from somebody? I don't think so. All right. And nobody has put anything. So sometimes it's hard for me to watch this and then watch the chat room in there and text messages on my phone, but I try to keep my eye on that. All right. So that's basically the task. You can see here's a sample problem from the assignment at the end of 1-1 where they ask you to do some substitution. So let's see. Yeah, so here we have a function g of or q of x equals 1 over x squared minus 9. What's q of 0? So you literally plug in a 0 for x, and you get your results. So you're going to have a number of those are really simple. Yes. Let's take a look at number 35. Are all of you, hopefully all of you are familiar with what we call piecewise functions. Let me So this particular problem, that's a piecewise function. What do I mean by that? It's a function defined in 3 pieces. So when x is less than -1, use the formula 3x minus 1. When x is between -1 and 1, then the answer is just 4. And when x is greater than 1, the result is x squared. So you just literally have 3 pieces or chunks. So here's the one when x is less than -1 down here. It's got a slope of 3. And it would, if it kept going, would intersect at -1, y-intercept of -1, but it only goes up to -1. And it doesn't include it, so we have an open. When it's between -1 and 1, then it's at the height of 4. That's this bar at the top here. And when it's greater than 1, then it's part of a parabola, x squared. So thought I might need to refresh that with some of you. Number 45, y equals, so we've got this function, x times the square root of x minus 5. I don't have the problem in front of me, so let me see if I can, yeah. Well, anyway, I'd like you to work on, and we have this whole deal here. Let me go back to the course website. When you get done with right underneath course resources, you see where it says calculus core exercises. That's the master for our assignments. And when you click on that, you get basically the assignments for the semester. So if you look at lesson 1-1, you'll see we're supposed to do 1 through 4, 19, etc. So for next time, I'd like you to do the 1-1 assignment. So always look at the core exercises. Now, I've got that copied right here. So basically, you know, this is your assignment for lesson 1-1. And it should be mostly review, but I don't know, you may need to go back and do some review. Also, you notice at the top of the core exercises, there are 2 links. You have to go to the website to see that. So I will do that. So when you're back here, you can click on these. These are WLC sites. So trig review assignment, and you'll see some keys come up there. And the trig you need for calculus. And there's all kinds of sublinks there. So those are important. We haven't talked about trig today, but during chapter 1, we need to do a quick refresher. I know you've had that in pre-calculus. So today, the main thing we need to do is function notation, and this ability to find a difference quotient is extremely important, because the difference quotient, when combined with something called limits, will allow us to do the first major thing in calculus, and that is find a derivative. So that's your task for next time. Does anyone have a question? Yeah, and Richard, I never did greet you. I see you're in there too. Glad to have you here. Does anyone have a question? You can unmute your mic. Remember, just move your mouse a little bit. This red-black menu comes down, and you can click on the microphone and make it unmuted. Well, then I think we're going to call it quits. Thank you. This is recorded, so you will see it appear in the video links on the main website. Thank you. Have a good one.